In this video, I'm going to walk you through the Agents module in Bud AI Foundry. The Agents module lets you easily create, experiment with, and deploy AI agents without coding or any heavy lifting. Before we dive in, let's learn about Bud Agent Runtime, the backbone that keeps your AI agents running reliably at scale. Building an agent is relatively easy, but deploying and maintaining agentic systems at scale is a real challenge. How do you handle thousands of simultaneous agent requests? What happens when a tool call fails in the middle of a workflow? How do you maintain context across steps and sessions? And how do you enforce guardrails without slowing agents down? And that's just the start. Identity, scaling, recovery, observability, the list goes on. Managing all of this manually would be a nightmare, which is why we built Bud Agent Runtime. Agent Runtime is the execution layer between your agent logic and the underlying infrastructure. It handles state management, orchestration, auto-scaling, communication between agents, tool integrations, observability, guardrails, and job scheduling. Real-world agentic operations can be unpredictable. Processes may crash, nodes may restart, networks could fail. But workflows shouldn't collapse every time infrastructure does. That's really why Bud Agent Runtime is built for reliability at its core. The way it works is, it persists every LLM call and tool execution into a durable state store. So when something goes wrong, agents can recover instantly and continue exactly where they left off. This isn't just simple retries. The runtime applies automatic retry policies, timeouts, and circuit breakers for transient failures, and durable retries backed by persistent workflow state for longer outages. Scaling agentic systems shouldn't require massive infrastructure overhead. Bud Agent Runtime uses a virtual actor model where every agent operates as a lightweight unit of compute and state. This allows thousands of agents to run concurrently on a single core with millisecond latency. And when agents go idle, the runtime automatically scales them to 0 while preserving their state, so they can resume instantly whenever needed again. Agentic systems can't operate on blind trust. As agents gain access to enterprise data, tools, and workflows, security needs to be built into the runtime itself, not added later as an afterthought. Bud Agent Runtime embeds security at every layer with unique cryptographic identities for every agent, encrypted communication by default, and fine-grained access controls that let platform teams define exactly which services and data stores each agent deployment can access. And with built-in OAuth, API token, and secrets management, agents authenticate to external services without ever exposing credentials. And you get full visibility into everything your agents do. Every tool call, every LLM interaction, every workflow step is traceable end-to-end. The real power of agentic systems emerges when agents can collaborate seamlessly. Bud Agent Runtime enables this through an event-driven architecture where agents can communicate, discover, and invoke one another dynamically. An agent can even use another agent as a tool within its own reasoning loop, including agents built on external frameworks, making it possible to orchestrate complex multi-agent workflows as a single intelligent system. And you don't start from a blank canvas. The runtime ships with 7 proven agentic patterns out of the box. From a simple augmented LLM and prompt chaining to routing, parallelization, evaluator optimizer loops, and orchestrator worker setups. That's Bud Agent Runtime in a nutshell. While your teams focus on building intelligent agents, the runtime quietly handles everything underneath, from durable execution and auto-scaling to security, observability, and multi-agent orchestration. The result is an infrastructure layer built to run production-grade agentic systems reliably at scale. Now let's see how all of this comes together inside Bud AI Foundry. Log into your Bud AI Foundry dashboard and open the Agents tab. Here you can view all the agents that have been created and deployed across different projects. Now let's create a new agent. Here you can select the project where you want to deploy the agent, and then choose the type of agent you want to build. These include simple prompt-based agent, add external agents, a workflow-based agent that supports more detailed multi-step prompting, an autonomous agent that can use custom tools and capabilities, and chat flow agents designed for guided conversational experiences. For this demo, I'll focus on the simple prompt-based agent and cover the other options in upcoming videos. This is the Agent Builder page, a simple and intuitive interface for building agents. Here, you define the inputs to collect from users, determine how the agent should process those inputs, configure the tools it should use, and specify the type of output it should generate. In this demo, I'm going to build a simple agent that analyzes a GitHub repository using external tools and generates a short summary. First, let's load a language model for the agent. Next, you can define the input. Inputs can be text, images, or documents. Depending on the agent use case, you can enable these options to support structured input, image, or document inputs. For this demo, I only need a basic text input. In the next block, you can add the system prompt that defines the agent's behavior. This is where you instruct the agent on how to process the input, which tools to use, and what output to return to the user. In this example, I want the agent to use the DeepWiki tool through its MCP server to analyze the GitHub repository, generate a summary, and return it to the user. Here you can configure things like retry limits, which control how many times the agent should try again if the model or tool call fails. There's also an option to allow multiple tool calls if the agent needs to use more than one tool during execution. Next is the prompt messages section. This is where you can provide additional context for the agent, such as chat history or any other information you want the model to consider while processing the input. This can be especially useful for agents like support assistants, onboarding helpers, or internal knowledge agents where prior context improves the quality of the response. After that, we have the output configuration. Here you can choose whether you want structured or unstructured output, depending on how you plan to use the response. One important step is enabling the external tool the agent will use. To do that, open the Tools section. You'll see a list of available tools and integrations. In this demo, I'm going to add DeepWiki, because that's the tool the agent needs to complete the repository analysis. Optionally, you can also add native tools such as web search, a code interpreter, and others from the native tools section. From the settings here, you can configure inference parameters such as temperature, token limits, penalties, stop sequences, and more. And that's it. The agent is created. Now let's test it. Click the play button to open the agent playground. From here, you can test how the agent works. Let's provide a repository URL as input and see the results. Next, go back to the agent editor and click the plus button to create a new version of the agent. You can experiment with different models, prompts, and settings to improve performance and compare different configurations and their outputs. This makes it easy to iterate on models, settings, and prompts until you find the best configuration for your use case. Once you're satisfied with the results, click Save. To use the agents you've created, go to the Projects tab. Select a project, and then open the Agents tab to view all agents saved within that project. From there, you can access code snippets to integrate the agent into your applications or other workflows. You can also view detailed analytics, including inference costs, usage metrics, token consumption, request metrics, and performance metrics. The Agent card provides a quick overview of the agent's settings and configuration. From the Observability tab, you can access detailed logs of agent interactions, which can help with troubleshooting and compliance. From the Versions tab, you can view all available versions of the agent and make modifications as needed. That's an overview of how to build an agent using Bud AI Foundry. In the upcoming videos, we'll explore how to build more advanced agents using workflows, autonomous capabilities, and richer tool integrations.